This is the video for Unit 3, Lesson 3, Writing Equations of This is the video for Unit 3, Lesson 3, Writing Equations of Polynomial Functions. The goals of this are going to be to write a polynomial function given roots, graph a polynomial function using degree, intercepts, coefficients, and end behavior. So in the previous video, we talked about the relationship between degree and behavior. So, for example, we saw if it was an odd degree, that the end behavior went in opposite directions. If it was an even degree, it went in the same direction. And then if it had a negative, this is if it was a positive leading coefficient. And if it was a negative leading coefficient, it was basically the reverse. So the odds still went in other directions. The even still went in the same direction. It would just be flipped. So for the first one, we're going to be looking at writing an equation of a polynomial of least degree. And they give you three different roots, right? So we have three roots and a leading coefficient of -2. So the first thing is we're going to rewrite the roots. We can rewrite it in our factored form. And so if you remember from back in Math 2, you talked about solving a quadratic in factored form, and you would take the each factor and set it to 0. We basically do the reverse when we have our roots. So if I have a -2, I would write as x plus 2. That would be a factor. If I have +5, I would write x minus 5 as a factor. And then if I have +1, I'd write x minus 1 as a factor. So if I wanted to write an equation in factored form, I would write all my roots as in a factor, essentially, and then the coefficient would be in front of that parenthesis. And so this would be my equation. I actually already know my intercepts, right? I know I have one at -2, 0, 5, 0, and 1, 0. I got that from my roots. And we're eventually going to go ahead and graph these out. My y-intercept, which is always kind of a good one to have in there. Your y-intercept, remember, that's when your x value is 0. And we're going to find our y value. So what we're going to do is we're going to substitute in 0 in for x and see what we get for y. So if I put in a 0 in for x, I'm going to get 0 plus 2, 0 minus 5, 0 minus 1. You maybe didn't have to write all of that out. It's really just -2 times 2 times -5 times -1. And if I multiply all those out, you're going to end up with your y-intercept, which for this one is going to be a -20. So my y-intercept is actually 0, -20. For the degree, I have 3 intercepts, so it's a degree 3. My leading coefficient, they told us, was -2. And based on that, I can now write my end behavior. So I know they're going to go in opposite directions because of the degree. And if it's a negative, it's going to start high and go low. So my end behavior is going to just do a rough sketch, something like this, right, where it starts high and goes low. So if we were to write our end behavior, it always starts the same way. When it goes to the left, when it goes to the right, what happens? So if we look at it, since it's negative, or since it's odd, it's going to go opposite directions, and it's negative, so it starts high and goes low, as opposed to what we're used to going low, and then starting low, going high. So this would point up, this one points down. And so far, this is all the stuff that we've seen in the past couple sections. The new part is now drawing a sketch. So what we're going to do, we're just going to kind of estimate. So our intercepts are -2, 5, and 1. So I'm going to put a plot at -2. I'm going to put a plot at 1. I'm going to put a plot at like 5. I also know that I'm going to have a a y-intercept of negative 20. So negative 20 is down here, and it's not to scale because it'd be hard to fit negative 20 on there. But basically, I know whatever I draw has to pass through these four points somehow. Some curve has to pass through there. And if I look at my end behavior, which I'm going to draw back over here, I know that I could actually do a kind of a connection where the last point on the left, I'm going to do an end behavior that way. And then my last point on the right, I'm going to do an end behavior kind of going this way. So I don't want to have something kind of going on there. And then you're just going to do your best to connect it. Again, we're drawing a sketch. It's not perfect. You want to make sure it looks curved, right? So you do your best to pass through all the points. And you should have something that looks like this, right? Not perfect, but it passes through all the critical points and then has the correct end behavior. For the next problem, it's kind of the same thing. So we're going to go ahead and see if we could answer all the questions we just saw before. So the difference with this question is it's in factored form already. So we can get the intercepts. Remember, we take the opposite sign, or it's like setting each factor to 0. So my x-intercepts, my roots are negative 4, positive 3, positive 1, and negative 2. So if I wrote it as a coordinate point, which you could do that if you like, remember those would all technically have zeros. For the y-intercept, again, it's like substituting 0 in for all of your x values. So it's really the same as multiplying all of these values. And then the leading coefficient's a 1, right? So I'm just really doing 4 times negative 3, negative 1, and 2. Because, again, the y-intercept is what happens when x is 0. So if I substitute in a 0 for x, what do I get for y? When we multiply all of that out, we're actually going to get a positive 24. Our degree we can get from our roots. So it's actually a degree 4. Our leading coefficient is a 1. And so we can actually sketch our end behavior based on that. So if it's a even degree, they're going to go the same direction. And if it's positive, they're both going to go up, or they're both going to go high. So you're going to have end behavior where they're going the same direction. So if I was to write that out, when I go from negative infinity, when I go left, when I go right, it always starts the same. Then what happens? And both these are going to go upwards. And so when we go ahead now and graph this, we're going to plot all of our intercepts first. So we have here negative 4, plot here, negative 2, 1, and 3. Positive 24, against not to scale, so we're just going to do our best to kind of sketch it. So whatever we draw has to go through these points. You could see our end behavior starts up, so I'm going to just kind of do a sketch. And then we're just going to do our best to kind of pass through all these points. So I'm going to go ahead and pass through all the points. So it makes like a W shape. And that would be it. The you try will have you try out. And then the last one is just writing it from the graph. So this one, actually, all you're going to do is write out your factored form. So I'm going to go ahead and write all these out. This is an example of one, though. You can see it is you can see the end behavior. It's an even degree, right? They're going the same direction. But you might only see 3 roots. And part of the reason for that is because, again, like we talked about in a previous section, when it touches the axis, this actually counts as a double root. This counts twice. So when I write my intercepts out, or my roots, I have negative 2, I have 0, which is actually a double root, and I have positive 2. If I rewrote it in factored form, 0, if you did the opposite of x minus 0, right, that doesn't do anything, but there's 2 of them, x plus 2, x minus 2. And then this actually simplifies to be x squared because I can, x minus 0 is just 0. And so if I was going to write this out, this would be my answer in factored form. This is by polynomial. You could also write it as f of x. If you have any questions, you can ask during class, sign up for T-Bolt time, or go to the center.